Hello, this is David Hall, and it is my pleasure to welcome you all to today's webinar presented by the IoT M2M Council and sponsored by ORBCOMM. Since its establishment 2 years ago by 20 high-profile organizations, over 17,000 adopter members have joined the IoT M2M Council, which has focused on making the implementation of IoT and M2M solutions simpler, faster, and more profitable for its member base. Before we start, there are a few items that I would like to bring to the attention of our viewers. Today's presentation will be approximately 40 minutes long, followed by a 20-minute Q&A session with our panelists. This is an interactive webinar, so we are eager to receive your questions at any time. Just type them into the Q&A window on your screen. Our speakers will address as many of the questions as possible during the Q&A segment following the presentations. Please address your questions to all panelists, which is the default setting in the Q&A box. This presentation will be archived and available for viewing later on in the past webinars section of the IoT M2M Council's website. At this point, it is my pleasure to turn the session over to our moderator, Robin Duke-Woolley, founder and CEO of Beecham Research. Robin has over 35 years of experience in the telecom and IT industry, first in commercial roles covering marketing management, sales management, and general management in international technology vendor companies, and second in marketing analysis and consulting roles. Robin has been researching the M2M and IoT market for over a decade and is an internationally recognized thought leader in this area. Robin?
Thank you, David. Well, we've got a great discussion for you today with Sue Rutherford from ORBCOMM. We're putting the spotlight on satellite today and discussing how satellite is playing an increasingly important role in the IoT world. I'm going to start this off with a short introduction to the satellite IoT market. Sue is then going to take over and develop that theme and the major part that ORBCOMM is playing in this market. We'll then have a Q&A session after that. So for that Q&A session, you can send me your questions at any time starting now. Just type them into the Ask a Question window on your screen, as David has just said. And I'll put those, as many of those as possible to our speaker, and I'll chip in as well later in the hour. So please start sending me your questions right now. So moving on to the first slides, I'm going to do just a brief introduction. Satellite IoT comes out of its niche, and I start my slides often with this one, which is our sector map. This is very common territory for all M2M and IoT applications. 9 key sectors rather, buildings, energy, consumer and home, healthcare and life science, industrial, transportation, retail, security, public safety, IT and networks. And many of you will have seen this before, and it applies equally well to the cellular space as it does to the satellite space. However, the next slide then shows key satellite application areas today. There are, in fact, satellite applications in all of the sectors, but in particular, energy, industrial, transportation, retail, security, public safety, IT and networks, where there are more of them. I think that we'll be focusing mainly on those sections in this presentation. So then, what do we mean by IoT applications in general? Well, we at Beecham Research split application categories into three. We have aftermarket applications, regulatory, and then OEM line fit. And we apply this to all applications, whichever technology is being used. So taking the first one, aftermarket applications, example for satellite use is ATMs in remote areas, fleet management across remote areas, and then, of course, things like environmental monitoring. And the example there is actually for a vineyard. So these tend to be low to medium volume per application. They have add-on networking, so it's a retrofit, going out and installing a connection link, in this case a satellite link, and then medium to high cost per unit, because there's quite a lot of technical support required, and that's sort of like the first category. Then there's regulatory, and typical applications there are road tolling. That's often used with cellular, smart metering, and then shipping regulations is one that would be appropriate to satellite. These tend to be medium to high volume during the installation phase because there's a big lump of things that need to be installed. And it's embedded networking. It's embedded in the device. So the device is typically designed for that purpose. That means that it's relatively low cost per unit, and it tends to favor a tendering process. And then the third area is OEM-based or line fit, where this is typically a product manufacturer wants to add a service to their product and therefore wants to include connectivity with the product. So this tends to be medium to high volume because it's like all of the products that manufacturer produces. It's embedded networking. It's embedded during the manufacturing phase, which makes the cost per unit lower. But this increasingly requires international coverage. Now, that, of course, is ideal for satellite use. And we have examples of auto telematics, jet engines being monitored while in flight, and construction vehicles, particularly in remote locations. So these are all examples of use by satellite at present, at the moment. But the thing to bear in mind is that for satellite use, most of the market is actually in the aftermarket applications. There are really not that many regulatory, and OEM-based is relatively small at the moment, but there's a big opportunity to grow that. So then we look at the forecast of up to 2020, what is happening in the satellite IoT market. And the annual growth rate is around about 12% per annum, perhaps a little bit more. And this is very much lower than the rate for cellular. It's about half the rate for cellular. And that's a reflection, really, of the fact that most of the applications are currently in the aftermarket area rather than the line fit or OEM area. So there is an opportunity for faster growth, with many new applications becoming viable as costs come down. And for satellite use, it's mainly business use at present, but there is a lot of consumer potential. And of course, there's a lot of talk in the marketplace at the moment about low power wide area. And that, of course, is low data rate, long range. So particularly into remote locations. In fact, LPWA is highly complementary to satellite, and we can see lots of opportunities for that to develop in the not too distant future. So I'm now going to hand over to Sue Rutherford, who is now going to take us through more detail of what ORBCOMM is providing in the marketplace. So I'm just going to give a brief introduction to Sue before she has a chance to say anything. So Sue, as the Vice President of Marketing for ORBCOMM, Sue is responsible for advancing the strategic direction of ORBCOMM marketing and its leading M2M IoT solutions. She has more than 2 decades of global technology marketing and business development expertise in telecommunications, software, semiconductor, software as a service, and industrial automation industries, and has led a number of multifunction teams working to increase constituency awareness and build market presence, customer footprint, and strategic business value. So, Sue, welcome to the session.
Thank you, Robin, and thank you very much for the introduction. I'm certainly very pleased to have the opportunity to join you in this webinar discussion today. So let's get underway. As I begin, I'd like to take a few minutes to just introduce you to ORBCOMM. Certainly on the screen, you can see by the numbers who we are. But for those of you not familiar with ORBCOMM, we are one of the largest players within the Internet of Things, or IoT space. We offer a full range of vertical-specific IoT solutions, as well as the components and tools required by enterprises, OEMs, VARs, and solution providers to build out their tools and their own IoT solutions. These components include hardware, a subscriber management portal, an application enablement platform, and most importantly, connectivity. In December of 2015, as some of you may have heard in the news, ORBCOMM and SpaceX made global headlines with our historic rocket launch and landing, which marked the completion of our next generation OG2 satellite constellation. This renews ORBCOMM's constellation and solidifies our position as the only satellite constellation 100% dedicated to machine-to-machine and IoT applications. As part of our expanded connectivity offering, not only do we provide cellular services through 7 Tier 1 providers, but we also offer additional M2M or machine-to-machine satellite data services, including both Inmarsat and Globalstar. With these capabilities and with 1.6 million subscribers and growing, ORBCOMM is truly in the unique position to understand the benefits of satellite. We work with real-world customers to help determine whether cellular, satellite, or dual-mode connectivity is right for their specific application. Moving to the agenda, I'd like to take a look at what we have ahead in the presentation. We'll cover a brief history of satellite. We'll look at some satellite advantages. We'll review some of the new developments in satellite. And finally, we'll take a closer look at a few satellite-enabled applications. So let's start with a brief look at the history of satellite communication. In the 90s, commercial satellite constellations gained traction as companies looked to provide global satellite phone services, and those to really overcome the shortcomings of early cellular networks, which were at times pretty unreliable and pretty expensive. In some cases, the satellites never really got off the ground, and in others, after the constellation was fulfilled, the voice market didn't meet expectations. Expensive airtime and hardware certainly didn't help with that. As a result, most companies that had launched satellites ended up struggling under the weight of their CapEx obligations. Satellite now is undergoing a bit of a renaissance, and we've seen and are about to see a number of constellation renewals. And we've heard a lot of talk about new constellations. The big difference is that these constellations now have M2M and IoT communication as a big part of their revenue strategy. The business case is really no longer built just around voice. As a side note, if you've been following, in the industry, references to both M2M and IoT, when describing satellite communications, both of those acronyms are used frequently. While we could probably spend an entire webinar reviewing the distinctions between IoT and M2M for the purposes of our discussion and in terms of providing connectivity, there really is no difference. From here on out, I'll be talking more about satellite IoT. Now, before we get too far into the webinar and too far into our discussion, when we talk about satellite coming out of its niche, I'd like to define what we're talking about. Although the lines are becoming a bit blurred, I like to think of satellite being split into 2 different types of offerings. Data rates are a way of describing the 2 types, but with data rates come some additional class-defining characteristics. Most of you are probably already familiar with broadband satellite connectivity. You can find examples on your roof with your satellite TV, or maybe it's streaming video devices for news feeds or reporting. These higher data rate broadband products are usually characterized by relatively large satellite dishes and are more or less restricted to fixed installations or bulky and expensive mobile installations, like providing Wi-Fi on cruise ships. What is less familiar to most is the other class of device, which is usually characterized as cheaper, smaller, mobile-suited, but lower data rate. While broadband products continually make progress with more efficient designs, faster and cheaper data rates, Some of the more interesting stuff is really happening on the narrowband class of device, which is what we typically refer to as M2M or IoT satellite. The product developments within this market have created significant growth, as Robin pointed out earlier in the introduction, and seem to be encouraging others to launch their own constellations. This is the satellite segment that we'll focus on for the rest of this webinar. So let's take a look at a few satellite advantages. Coverage is the #1 value proposition for the majority of those who decide to pursue satellite connectivity. This will likely never change, but there's one lesser known value proposition, but there are more lesser known value propositions offered by satellite that either complement coverage or stand on their own as a reason for using satellite. One of the key benefits that certain satellite systems can provide is enhanced reliability. Satellite availability can be better than 99.9%, providing a service level that cellular can't guarantee, especially when you broaden your scope outside of an urban area. Cellular reliability is quite good, but we'll see later there are certain conditions that can compromise cellular service without affecting satellite service. While this is mostly centered around infrastructure, location, and environmental conditions, there's also a congestion element present. The high reliability of satellite can encourage satellite-only solutions in some cases, and in others provide an independent, redundant channel to primary cellular connectivity. In terms of longevity, the life cycle of a satellite network is quite long. All of these constellations are expected to be backwards compatible with technology life cycles of 20+ years. Let's compare that to the longevity of cellular, where we're seeing 2G sunsetting, 4G is replacing 3G, and 5G has already begun trials. The lack of local infrastructure required for satellite communication is also a key benefit. There are other communication options for remote areas, but they come with a great amount of time, build-up, and expense for new infrastructure. Another benefit is the satellite IoT generally works globally, meaning you not require multiple product variants to satisfy your geographic needs. The fifth value proposition comes from a satellite IoT network typically offered up as a proprietary closed system, enhancing reliability and offering greater security. Multicasting is the final benefit, and it is a new development specific to a couple of satellite IoT providers. For clarification, when we talk about multicasting, it refers to broadcasting a message to a group or a subgroup of subscribers as a single billable event. With satellite's large transmission area or the beam size, a single broadcast can reach multiple units, driving down costs for certain transmissions. We'll touch on how these value propositions drive solutions a little bit later. Depending on how familiar you are with satellite and with the satellite industry and how long you've been exposed to the technology, you may recall some of the traditional limitations of satellite that today form the basis of common myths and misconceptions about the technology, like satellite airtime is expensive, or satellite can only send bits and bytes of data, or satellite hardware is a bit big and clunky. Innovation and increased demand have changed a lot of this. We're seeing technology as a catalyst for driving new developments across satellite IoT offerings, making it the preferred option for various applications. Devices, and satellites too for that matter, have become smaller and cheaper and more powerful as a result of advancing technologies and increasingly accessible markets. And that has prompted new generations of cost-optimized modems and terminals based on dedicated satellite chipsets. Where before these devices were capable of sending data measured in bytes, we're now seeing devices that can efficiently and cost-effectively deliver data measured in hundreds or thousands of bytes, enabling all sorts of new applications. Satellite has also managed to hit mainstream with successful consumer products. It's no longer confined to slow, bulky, expensive devices. Satellite IoT has a brand new life. Satellite IoT requires certain innovative improvements in order to provide an efficient, power-optimized solution. There are some satellite IoT services that offer IP connectivity, but the majority don't. The alternative is packet data, a much more efficient data exchange method that has none of the overhead an IP transaction would, especially for simple reporting like GPS location. This is a distinct advantage as satellite traffic is generally billed per byte, typically subject to a minimum message size that is much smaller than a minimum cellular connectivity fee. In some cases, based on regular scheduled reporting, the overhead in IP traffic can cause an increase of more than 20 times the data used by satellite. Satellite providers have taken steps to simplify integration of this protocol for users by including parsing, compression, expansion, and offering multiple access methods at the data gateways. One of our key initiatives at ORBCOMM has been the device cloud, which abstracts data from devices in order to have messages presented identically, whether they originate from satellite or cellular. Tools have also cropped up to make things easier for satellite integrators. As we offer multiple satellite and cellular options, ORBCOMM has also developed a single portal from which you can manage all your subscriptions and billing, enabling satellite connectivity management as simple as cellular. Blended satellite cellular data plans have also become available, recognizing the value of having satellite as a backup to primary cellular communication. Devices have become smarter with the ability to compute least cost routing with dual-mode cellular satellite connectivity, which automatically chooses the most cost-effective messaging option at the time. You can also now have the power to perform intelligent data retrieval and filtering. In other words, you only transmit the data you need when you need it. So what can satellite do for you? Let's take a look at some of the reasons why customers have opted for IoT. I mentioned earlier one of the key benefits of satellite is being able to provide a communication link to a remote area, which can be used to deliver information to help your business. This is one of the main advantages of satellite and is one of the most popular reasons we find businesses deploying satellite. I wanted to share with you some real-world examples of applications that have required remote satellite coverage. The first example takes place in open ocean waters, where satellite is the only communication option. With the development of small omnidirectional power-efficient modems and terminals, fishermen are able to deploy fishing buoys or fish aggregating devices and monitor them remotely until these devices report back that fish are ready to be caught. For the next group of applications, dam water leveling monitoring, water metering, and pipeline cathodic protection, satellite connectivity is used to reduce the costs associated with sending personnel to these remote locations. For dam water monitoring, satellite offers a real-time stream which can offer the opportunity to take action should water levels become a concern. Without this remote connectivity, the action would be delayed until the next visit. For water metering, real-time data not only reduces the need to have a technician come and read the water meter every month, but can also identify issues such as leaks or inappropriate usage and take action. An added benefit is that the customer can see a much finer granularity in their consumption, leading to more efficient usage and awareness. But satellite offers remote regions other advantages, and more than just coverage. Some regions are more inaccessible than others, rendering installation or on-site visits an expensive proposition. Imagine having to deploy a helicopter to reach some remote mining infrastructure. Satellite can offer a hardware solution with a long life that's not dependent on local cellular infrastructure. As an example, ORBCOMM's OG1 modems have been working for 15 plus years and are backwards compatible now with our new OG2 network, and will deliver another 15 years of operation. For inaccessible remote regions, the ability to install once and not have to upgrade the device for a longer period of time can significantly lower cost of ownership. And while the hardware is not upgradable, some satellite protocols offer the ability to upgrade firmware over the air to keep your solution current and effective. So you could outfit a remote region with other technologies to form a local area network, such as cell towers or private radio networks, but satellite backhaul may still be required. So why not just start with that? A secondary benefit of satellite is the possibility of quickly creating a connection without any dependency on local infrastructure. Using a satellite terminal also requires no antenna pointing, no point-to-point RF towers, and no cellular infrastructure. Everything you need to establish a connection is either in your hands or out in space. Plus, you're not relying on local infrastructure with local regulatory bodies, frequency plans, and protocols. Satellite devices speak a global language and are able to provide connectivity anywhere in the world with the same platform, with no additional administrative costs or roaming fees. Global or pan-regional deployment is made easy, whether you require connectivity in remote areas or not. So let's take a look at a couple of applications where having easy infrastructure is beneficial. We've talked about the requirement for having a solution that can work anywhere. This is important for the companies that span multiple countries or even globally and that have equipment that moves around. Cellular connectivity is not uniform across the globe, so these companies may be susceptible to different product variants, as well as possibly expensive roaming agreements. Satellite provides an excellent way to mitigate this. The other key application is the quick deployment of communication equipment to respond to emergencies. Sat phones are a definite example of this, but there are also humanitarian missions or other support functions where you need to track equipment and personnel. When local infrastructure can't be counted on due to destruction or congestion, as is often the case in disaster situations, satellite can provide vital communication links. We'll carry on our theme of easy infrastructure in this slide. As I mentioned earlier, some satellite services are able to offer better than 99.9% availability. Part of this reliability can be explained by the remoteness of the infrastructure equipment in space, which is much less susceptible to natural disasters or extreme weather or power outages. Satellite can also provide an independent channel to alleviate congestion issues. The reliability factor manifests itself within solutions in a number of ways. In today's age of IoT, which offers increased visibility into a great many things, we're seeing quality of service really becoming an essential point of differentiation. And in some cases, that quality of service requires a high level of uptime. The first example speaks to the communications link reliability. In the past, cellular and private radio networks have been used to provide communication links between utility companies and their equipment. However, the reliability of the communication service has caused problems with the company's ability to maintain their SLAs and have resulted in significant financial penalties. Some of these companies have looked to use satellite to provide a more reliable real-time awareness picture of their equipment, either as a primary means of communication or as an independent and complementary channel to cellular. Satellite has found a popular home within the cargo security market. Trucks carrying high-value goods can be exposed to cell jammers from hijackers, rendering communication platforms useless. In some situations, satellite provides an alternative means to alert the transportation company that something has gone wrong. This can help deter thieves from stealing cargo, but also increases the security and safety for drivers. In other solutions, satellite is a foundation to help protect human life. Whether workers roam outside of cellular coverage or not, knowing that satellite can offer you a primary or secondary means of communication is a good insurance policy. The same can be said for tsunami warning systems that include satellite connectivity. These are also absolutely relied upon to prevent tragedy. Now let's take a look at dual mode. The concept of dual mode, where a device provides two independent means of communications, typically cellular and satellite connectivity. Cellular is sufficient in many cases, but there are a number of situations where it's not. There's a great ROI story with cold chain logistics applications. Having satellite provide backup communications to cellular offers full-time trailer location awareness. Not only does this allow for more efficient logistics management even outside of cellular coverage, it can also ensure communications during emergency. For example, if there's an incorrect temperature setting or reefer malfunction, which allows for some kind of proactive action, like contacting the driver or resetting reefer temperature points. This can greatly reduce lost revenue due to spoilage of goods. In other words, your ice cream doesn't turn to sour milk. We have a similar story with fuel monitoring. For mining companies, cellular connectivity may or may not exist, but the equipment still needs to run and critical alerts still need to get through. A particular implementation of a fuel management solution involved having trucks consistently report fuel levels, which are then communicated to drivers via alerts to signal an appropriate time for refueling. Knowing the fuel level and removing guesswork enables fewer stops per vehicle and increases productivity. In dual-mode solutions, cellular is typically used to provide service most of the time. What we find in many cases is the fear of what will happen if connectivity is missing, and that prompts the inclusion of satellite. Satellite offers a secondary means of connectivity to ensure business continuity, which includes cheaper hardware, least cost routing, and recurring monthly charges for blended satellite cellular data. In some cases, the supported cellular service may be deprecated. The device may enter a region in which roaming is expensive or the cellular frequencies aren't supported. In all these cases, the device cost effectively maintain connectivity via satellites. As hopefully you've seen throughout this webinar, the satellite industry has been making great strides to advance technology and offerings. Devices are smaller and more capable, and connectivity is far more cost-effective than we ever imagined 10 years ago. Satellite IoT will always have remote connectivity as its key value proposition, but we've also seen many reasons for choosing this form of communication, even in less remote regions. In a widening variety of markets, businesses are increasingly turning to satellite to improve efficiency, productivity, and risk mitigation. Satellite IoT is truly coming out of its niche. I'd like to thank you so much for joining us today. And now, Robin and David, I'll pass back to you as we open up to questions.
Turn to our first question. And this is, how will low power wide area affect satellite? Sue, perhaps you could start with that.
I'm sorry, and that was, what was that question, Robin?
Oh, I'm sorry, yes. So how will low power wide area affect satellite?
So I think that there's a few things to speak to here. I think that there's some new types of M2M IoT technology with low data rates and looking at the remote areas. These networks still need some backhaul. Networks are generally low data rates, and satellite IoT can provide some backhaul, but you still need the infrastructure for LPWAN. And still a little bit unclear on reliability and the latency of networks. I'm not sure if there's something else, Robin, that you would like to add to that.
Well, I think it's useful just to draw some application areas that this could be effective in. So, for example, in the smart farming area, low power wide area is going to be, I think, very effective for monitoring herds of cattle and things like that, and perhaps environmental monitoring in remote areas. But then they need to bring that information to a hub, and then that needs to be then transmitted back. So there's the opportunity to have a remote hub. Also, I think there is increasingly an opportunity to have direct connections for remote locations from low power to collect the information back to satellite. So I think that there are possibly opportunities there as well. So that's the first one. So the second one, Sue, is what market do you see satellite as gaining most traction? Which application areas do you see satellite as gaining most traction?
So I think one of the areas that we're certainly seeing from ORBCOMM is cargo security, and that it's always been a really good ROI story, and in the fact that there's such high value goods that are transported. When we look at the carrying of electronics or pharmaceutical goods, heavy equipment as well. There's a number of many number of pieces of equipment in remote areas, and they tend to have global coverage requirements. It's also very expensive equipment, so a high cost of operation to understand where things are and what's happening with the operation of those. Vessel monitoring systems is a regulation-driven requirement. We've certainly seen that application area gaining steam. And, we're seeing a lot of emerging applications in Latin America with utilities and the service level agreements with needing to be on there. So I think there's a few different areas, a few different application areas that we're certainly seeing as gaining more traction.
Yes, okay. Well, that's great. And then the next one is, how does narrowband satellite M2M solutions manage inclement weather? Or does it need to manage inclement weather as well, I suppose, is probably the point.
So I think that, again, there's a few areas where narrowband is at a lower frequency, so it's not as susceptible to weather. That's really where it's a typically higher frequency broadband issue, which is why lower frequency devices actually serve as a backup to broadband devices, or why they're used for emergency management during extreme weather events. Yeah, I think that's more
okay.
to.
All right. Actually, sort of related to that, you talked about jamming of GSM, and that's quite an issue, really, isn't it? Because it's not so easy to jam a satellite signal. Would you like to comment on that?
So it's not, and where we're seeing a lot of that is certainly in Latin America, where we have both the security of the cargo that's being transported, as much as it is for the drivers that are driving the vehicles, and so we do have with satellite the ability to really kind of I guess provide that intrusion that you're not able to. We do eliminate the jamming,
right.
if you will.
Yes. So also, of course, they're pointed at the sky, which makes it somewhat more difficult to actually interfere with the signal.
That's right. It's not. Yeah, it's not like the cellular devices.
Yes, and I think it's possible to buy a GSM jammer. I hope that everybody doesn't go out and do this now, but it's possible to buy a GSM jammer for a relatively small amount of money. I suspect it's probably quite expensive to buy a satellite jammer, even if it's possible to get one.
Yeah, and more to the point of not. Yes.
They're just not available. Okay.
That's right.
All right. The next question is, so how much does satellite connectivity cost? There's this view in the marketplace, I think it's generally acknowledged that satellite is reckoned to be expensive and therefore not cost effective compared with other alternatives like cellular. Would you like to comment on that?
So I think it really, there's a number of variables involved, Robin. I think that it varies across the satellite IoT providers. It also varies across the applications and what the end use, what the requirement is. Typically, the cheaper the hardware, the more expensive the airtime. think that, data exchange rates from bytes to kilobytes are plans from $1 to $2 to $50 or higher, depending on what the application needs to send. So it is also very, dependent upon the specific application.
Yes. Okay. All right. Yeah. All right. Would you say that it can be much cheaper than cellular, or is it always going to be more expensive than cellular? So what I'm thinking is that for some applications, you only need a few bytes of information. You don't need very much, and that means that you can probably balance the costs at a lower level for satellite in some instances, compared with cellular, which tends to be charged on a different basis.
Right, and I think
comment on that.
Yeah, I think it's all dependent on the amount of data that you're requiring to send and how frequently those messages need to be sent. You can look to send messages once a day, or you can send them more frequently, depending on your application. But of course, with the less frequent and with the low data rates and sends, then satellite does become much more economical than it was previously. Again, it's really based on the requirement of how much you're needing to send and when. And some people don't require all of that data. I mean, what we're looking at is very much more the smart data. There's lots of data. It's being able to call that data and send what you need when you need it.
Yeah, I think that's a really good point, actually, because when I look at M2M satellite solutions, they tend to be like engineered. There's a lot of thought that goes into what data you actually need to send, rather than sending everything. Whereas perhaps for cellular, there is more of a tendency to send everything and then sort it out at the far end.
The other thing, Robin, that we do at ORBCOMM too, in various applications that we have, various software applications, is that we can help to create the various reports that people need and then set up the frequency of those reports. So it really is looking to put into practice more economical kind of reporting, right? It really does come back to that management of the data and what you're needing to what you're needing to receive for your business operation efficiency. It's really looking at the right data when. Yes,
indeed. Okay. Well, let's move on to the next one. Do we currently have solar-powered satellite devices?
So we do, absolutely, and we do at ORBCOMM. We have a product, one of our flagship products actually is a GT1100. And with other ORBCOMM devices too, but we've installed in many instances with solar powers as a power source in remote areas.
Okay, and then the next one is why don't we need to steer the local terminal in the ORBCOMM case? I'm not entirely sure what that means. Does that make sense to you?
So I'm wondering if they're speaking to the antennas. So for ORBCOMM,
right.
So for ORBCOMM, our antennas are omnidirectional, which means they can work in any direction. So there's really no pointing necessary.
Right. Okay. Yeah. So it picks it up wherever it is, even on the horizon, I guess. So there's no need to point it at the actual satellite. In fact, they probably don't know where the satellite is. Is that right? Because the satellite could be it moves across the sky quite quickly.
Right.
Right. Okay. And then, can you give examples of some types of solutions you use at ORBCOMM M2M for data satellite IoT, like transportation, energy, maritime, utilities? I think you gave some examples actually, but maybe a few more examples.
So for, we talked about the cargo security. We talked about the, we do both refrigerated transport and dry van transport, where we're managing to send not only manage where the fleet are, but what they have in their transports and being able to redirect empty vehicles when they for a quick turn, for a quick pickup. So we do that. We talked about some of the fishing, but we also do more multimodal transportation. So that taking containers from the oceans, from the seas, into the ports, and then being able to move both cargo and containers through from ports into distribution. So we can do, we can monitor from the complete supply chain, so end to end, from where it's first loaded, where it's sent, and then where the distribution out through to the various locations. ORBCOMM also has a unique position in terms of just how we go to market, and we work directly with end users, but we also work with our value-added resellers. So, we have that complete end-to-end solution that we offer up, but we also offer that to our value-added resellers, where they can then take parts of our solution and incorporate that into their own solution. So take our hardware and our connectivity and build out some of the applications. And that's where we see some really interesting applications where they're going into whether it's water monitoring, or we're seeing a fair bit of pickup with the agricultural applications within both the States and in Australia, where people are, businesses, where farmers are looking to monitor what is happening with their soil and with harvesting and with the management of crops. So, it's really, the imagination can run with the various applications and what people are looking to do. But again, with our direct, to end users, and then through the indirect mode, we do see a number of emerging application areas.
Yes, that's really good. That kind of touches on another question, actually, which so it's very, very closely related. So do I purchase the entire solution from you, or can I continue to work with other providers? Do I have to use your sensors if I use your satellite network device?
So good question, certainly a good segue from what I just commented on. Yes, I think that from the entire solution, purchasing that from us or from one of our providers, it really is dependent on what the requirement is. So a solution might need an application, connectivity and connectivity management, or devices and device management. Some companies specialize in parts of this solution, in parts of the full solution. And so we offer all the tools required to build a complete solution. So whether we're doing that directly, or whether we're working with some of our providers to assist with some of the parts for them to do that. With the question about do you have to use our equipment? No, it depends again on the device. Some devices are application specific and integrate specifically with sensors, for instance, with specific sensors. Others, like our programmable devices, can take in sensor data and filter and parse and determine actions based on that input. So we can work both ways, which I think is sets us apart in the industry in our ability to do that.
And you do that in all parts of the world, don't you? What are the main regions that ORBCOMM operates in? Can you just say a bit more about that?
Yeah, so we certainly are a global organization. We have a very strong footprint in North America. We are our head office is based out of Rochelle Park, New Jersey. But we have a large footprint in Latin America. We did part of the organization really established that foothold in the transportation area, so fleet management and logistics and tracking. So we have a strong presence there. We also have a strong presence in Europe and in Asia. ORBCOMM, Robin, as you know, has grown by acquisition, and with the growth of acquisition, we have built out our customer reach and our footprint geographically. So a number of our acquired companies have assisted us in being able to scale and expand our footprint, and certainly that is what has happened with a lot of our expansion and is prevalent in some of the customer penetration and large pools that we have.
Yeah, that's really interesting. I'm going to ask a question. I'm going to be really mean and ask a question myself, actually, related to that, which is, so you've actually expanded in particular areas, haven't you? So particular value-added services that you've done a particular amount of acquisitions in. So you've become like specialists in particular areas as well as being a satellite operator. Would you just like to comment on that?
Sure. I think that, one of the premises, as I mentioned, of where we got our start and where some of our strength is in the transportation area as we look at fleet management and tracking and so on. But, as much as we are, looking at the general tracking aspects of our business, we have started to specialize in more of these vertical applications, vertical segments in those vertical applications that fall from that. And that because there are so many different nuances. And so for us to be able to create more value add, and by more of those value add, I mean more of the software applications and more of the portals and platforms that really are built to help for ease of use and for quicker time to market for our customers, and whether those are customers or our direct customers or there are our channels, it's all about getting time to market and getting providing the information that those customers need to have and the immediacy of that. And we very early on in the presentation, when I had the ORBCOMM as by the numbers introducing the company, we have over 300 engineering staff on board, and we're very proud of that. In that, we really do have the experts in our company that are able to really innovate and put forward some pretty world-class technology and devices and applications. So, we've certainly, with the experience and expertise of all of those people in the different areas that they've grown from and have brought into ORBCOMM, we've got a pretty far wide-reaching capability and expertise.
That's great. Yeah. Okay. So you talked about Dualmode solutions earlier on. Can you just say a little bit more about how that works? How you get the movement from, say, cellular to satellite? That's not a human intervention, is it? It's an automated intervention, I guess.
It is. It's really. It goes back a little bit. I made mention of the least cost routing. So that is actually the term that's used when there's the decision being made as to whether we go, whether we send the data through satellite or we send it through cellular. And sometimes we just don't have a choice because, as we talked about with remote areas, there just isn't a cell signal. So we need to send it via satellite. There are some cases when sending a message could be cheaper via satellite than cellular, in which case it's not the cell signal that determines the route, but the data plan. So, that has to be considered as well. And we find that this logic, should be built into the device and not really require user input. So it's done in the more sophisticated dual mode devices.
Right. So that's quite important, actually, because it means that ORBCOMM is operating both on the satellite network, but also on the cellular network. So
that's
you have,
right.
You have elements in both camps, if you like.
Right, and we have, we formed partnerships, very, very solid partnerships with, some of the top tier cellular carriers around the globe. And again, important to our business because we are international to have formed those relationships so that we can offer up to our customers both the cellular and the satellite. And in most instances, just by virtue of the volume and the business model, we're able to offer up very significant cost savings on those data plans.
Okay, I'm just going to ask a last question then. Is there a sweet spot of amount of data per transaction for satellite transmission?
Good question. There's usually a minimum message size, which can vary down to about 10 bytes. So messages are billed by the byte, so any length is a good length.
Mm-hmm. Okay, all right. Well, I think that's about all we can do. I think we're about sort of out of time. So thank you very much, Sue, for your answering the questions there. So now we need to go back to David at IMC.
On behalf of the IMC, thank you, Robin and Sue, and thank you all for joining us today. A recording of today's webinar and a PDF download of the slides will be available within the next 48 hours on our website, IoTM2MCouncil.org. You will receive a post-event email which will include information on the recording and the slides. Thank you all for joining us.